was on non-mute by default.
Oh, that's how's the situation in Ireland, Mihai?
It's sunny. No, it's kind of bad. Like, people are not taking this seriously enough, and I'm kind of scared a bit that things will just go really bad both in Europe, USA. I don't know what's happening. Like, it's just mad.
Oh, no.
Yeah, it's pretty chaotic.
So the Prime Minister of UK now has the thing, and that's
right. Hey, Chakra.
Hello.
We'll do introduction. But maybe we were talking, is Ireland in lockdown, or are people still kind of outside?
Yes, I mean, it's still lax. It's not like you cannot go out, but yeah, it's pretty locked down. Like, supermarkets are the only thing that's open, basically. It's kind of scary times.
Yeah. hopefully things get better.
How are things over there? Like, I don't know much about what's happening in the US now.
I'll introduce you to like Philip and Michelle and let them answer. Philip, how are you feeling? Philip's one of our engineers.
Hey, nice to meet you. Yeah, things are pretty quiet in San Francisco, I'd say. There's not maybe like there's stuff going on, but it doesn't feel like an emergency. They do have us locked down, so I don't really go out and see many things, but there's not too many news stories coming out about SF. New York's having issues for sure. That's the main news story, news cycle I see. Yeah.
Cool.
Yeah, it's pretty bad over here.
Are you in New York?
Yeah, I'm in New York. It's real bad.
Yeah, wow.
My name's Ruz, the engineering manager at Lyft for observability. They're starting to put makeshift morgues together next to hospitals.
Oh, no.
Wow.
And I talked to my neighbor in the floor that I live in. She's a ER doctor, and she said they're telling people that have pneumonia to go back home, as in they are starting to prioritize people and tell them like, we literally don't have space for you, and they're effectively telling people to go home and die.
Shit.
Wow.
It's pretty bad.
That's sad.
I mean, I hope the rest of the country realizes how bad this is, and so they at least learn that they have to be prepared, because New York is about a month ahead of everyone else. And we have high density. This is what's going to happen to high density cities.
Wow.
So maybe for a bit of good news, I was following, there's a guy called David Sinclair who I'm following, and he writes some nice things that are kind of insightful, and one of them is that this does seem to follow the pattern of the seasonal flu. So April is kind of the last month of the flu season, and then things should be a bit less bad, hopefully. But we don't know yet.
10:35. Let me just send out an email. We have a packed agenda, so we'll get started at 10:35. Looks like Kelsey's joining. We have quite a few time zones. So actually, we got to give a shout out to Takanori in Japan. Hopefully it's in the recording. He's by far the undisputed most heaviest Pixie user, but it's like 2:30 a.m.
Oh.
India, Europe, and East Coast, West Coast. All right, so cool. Kelsey, can you hear us?
Yep.
Awesome. All right, so let's get started. 10:35. So we want to just keep it as a pretty loose, open kind of working session, and we'll have like two big sections. One would be us kind of walking through the current state of Pixie, the product, and also giving you a sneak peek, kind of preview of what's coming in the next 4 weeks. So everything that we demo, we will ship. If we don't, I guess throw eggs on our face. And then the second half, we want to basically keep it kind of an open kind of discussion. We have Kelsey joining, and then Ruz has done pretty much everything in the observability space possible. So we have kind of folks who know a lot about this space. So we'll have two categories of questions. One would be like questions for Kelsey or Ruz. or anybody in the forum. And the second is questions specifically for Pixie, and then Zen and I will kind of go through them. So that's a rough format, but again, like, goal is to make it a working session. As we go through the Pixie stuff, feel free to just call out or raise your hand in Zoom or just ping on the Slack channel. And so you don't need to wait for questions. So with that, let's just get started. So Zen, go for it.
Sorry. Yep. So I'm just gonna keep this like pretty, collaborative, and feel free to dive in, ask questions. So the first step is basically go over, give like a high level overview of what Pixie's doing, and then I'll go through like some deployment scenarios and actually show like some sample usages of Pixie. And feel free to ask any questions. So at a high level overview, Pixie is an easy way to go and do low overhead capture of full request data and other metrics inside your Kubernetes cluster, while maintaining data isolation in your system. So part of what we do is that we basically insert these things called Pixie edge modules into every node as a daemon set in Kubernetes terminology, which means that there's like a privileged piece of code that's running inside of every node. And that particular piece of code will basically go and monitor all the applications or services and pods that are running on that node. And this is done by a few different things, right? The first thing we use is this thing called BPF, which stands for the Berkeley Packet Filter. But at this point, it's turned into like a pretty full-fledged, almost like virtual machine in the Linux kernel that allows you to go and capture data in a safe way. So that's one thing we do, and we use that to like trace all like the system calls and network accesses that happen on the machine. The other thing, of course, is that we use like standard Linux APIs like proc and all of that to capture some of their data. And eventually we'll plug into other systems like statsd and logging systems. So one of the issues that you run into when you do this is that it's actually just a crap ton of data, right? We take a look at live request bodies for everything. And most of the data is actually not that important. The most important data is like stuff that's causing problems, or there's some like interesting characteristic to the message. So the reason we call these edge modules instead of agents is that our edge modules are actually a lot more sophisticated. We not only do the actual data capture in our edge modules, we actually do a fair amount of data processing. So part of the idea is actually to push the compute as far down as possible so that we don't use up like resources, in the whole stack. So we don't have to transfer all the raw request bodies, all the raw data. So what happens is in the edge modules, we basically hang on to a small amount of data over time, and then we will proactively ship that data over to the command module or ship it over whenever there's a script that executes that requests the data directly. Which brings us to our second point, which is the consumption model of Pixie is basically built around like programmatic access. And this, basically is what we call like command-driven interfaces. And this happens on both the interactive side, where you have like a CLI, or like a non-interactive side where you want to, put this in some CI job or something like that, all the way up to the UI, where even the UI is actually just an expression of a bunch of, Pixie scripts. And you'll see how that works throughout, as I go through the demo. Any questions on this or thoughts?
I copied over the architecture diagram on the Slack channel in case people want to scan it. Kind of.
I'm sorry. That was my bad. Yeah. I was like, I'm presenting this architecture diagram. Sorry, give me 1 second. Before this, Pixie was like a fully not remote team, so we're not super used to. Can everyone see this?
Yes.
Yeah.
Sorry, 1 second. Let me just get my computer set up. Okay. Yeah, I meant to show this architecture diagram, which will be a lot easier to understand. So I'll just quickly walk through it again, just so that it's easy to see. So basically, there are these things called edge modules that we install inside of every Kubernetes node, which is basically managed by a set of YAML files. And then there's a thing called a command module, which is basically responsible for aggregating data and storing data across the edge modules. And then there's basically kind of like, two consumption models for us, right? And they're all based on the API. And it's essentially the CLI or the UI for us. And they basically all talk to our system through the API. We have a Pixie cloud, which basically is the control plane. So we do almost all the data processing on the cluster, but we have a control plane in the cloud, which does all the authentication and high level like control flow stuff in our system. In the community version, the cloud version does do a reverse proxy. So we proxy the data through our cloud, but we don't actually look at it. And mostly that's because it makes it a little bit easier for people to try it out and to work with it without having to worry about setting up all the firewall rules correctly to make sure you can access the cluster directly.
Cool.
Any questions on this?
On the architecture? If not, we can jump into the fun stuff. Cool. Go for it, Sam.
Okay, awesome. So I'm just going to walk through like an install of Pixie and then do a, sorry, my, okay, I'm just going to basically walk through a demo of Pixie and then install a demo application. So the demo application we're going to work with today is SockShop, which is actually an application by Weaveworks, and it's kind of like a canonical microservices application to try out.
Can I pause a little bit? So quite a few folks have been like obviously trying to update and upgrade and like install Pixie. So Chakra and Rupak, not to kind of call you out, but so what we'll do is like as we go through deploy, we'll walk through the steps. If you have any questions or suggestions as to how to make this more transparent, just let us know. We're trying to like optimize this so that we're like open with the end user about what's happening. So just let us know. All right, cool.
Yep. Yeah, feel free to ask any questions or give any feedback. So at a high level, basically log into Pixie. So you go to work.withpixie.ai and let me log out. Just to go from the beginning. Can't spell. Okay, so you log into Pixie. You can create an account if you don't already have one. You currently sign up using either a G Suite or a regular Gmail account. So I'll log in to Pixie with my account. I don't have any clusters set up, so it basically gives me a command to go, install Pixie. So what this first command does is it basically downloads the Pixie CLI. Which not only provides like administration capabilities for Pixie, but also provides the ability to actually run scripts and commands against the Pixie cluster. So after I do that, it'll basically ask me where do I want to install Pixie, and it picks a default path for you. Depending on the setup, it'll either pick like user local bin or your personal bin directory. That in mind, I'll just select user local bin. And what it does at this point is it basically installs the CLI. So it downloads the CLI off the internet, installs it, and then it asks us to go and authenticate with the Pixie cloud. This authentication is actually so the CLI can securely connect to our system. So I'll go select the same account. And at this point, Pixie is installed. Let me just double check the right version. Okay, cool. Excuse me. So the CLI gives you a few extra steps. You want to make sure that the CLI is in your bin, or you have to type in the full path every time, or in your path, or you have to type in the full path every time. The first thing to do is basically just run something like PX deploy. PX deploy will just deploy Pixie on your cluster. But before I do that, I'll actually show a new thing that we added, which is called PX demo. And we can say like PX demo list, and it'll basically list a set of demo applications that we have, pre-cooked inside of Pixie. So what I'll start doing, I'm doing this first because it takes a little bit of time. I'll basically go and deploy this demo application. And Pixie looks at your kube config file to find the cluster. And it's like, okay, I'm connected to this cluster on GKE. Is this a cluster you want to deploy it to? I'll go ahead and say yes. And this should go ahead and deploy the demo application. At this point, it tells me to go wait for the load test to get done, which is going to take a while. So while that is happening, let's go ahead and actually install Pixie on the cluster. So we just finished installing it, look a random demo application, but we really want to get Pixie installed. So when we do that, we can just say Pixie deploy. And again, it does the same thing. It goes and finds your cluster based on your kube config files. In this case, it found the same cluster again because I didn't change my Kubernetes config. And this other cluster ID is a cluster ID that Pixie associates with your cluster. So we can say yes. And what we do right now is, we go through and essentially set up all the YAML files. There is a way to dump out the raw YAML files if you're interested, but for the most part, we just install the YAML files in sequence. We don't have anything too fancy like operators or anything like that. So it's for the most part just like Kubernetes config and YAML files. And we just wait for Pixie to come up in a healthy state.
Then you might need a laptop charger.
Yeah, it was just plugged into my iPad, so I am now plugged into my laptop. I just noticed that.
Cool.
So this step usually takes, like a minute or so. It really just depends on. Sorry, Zoom is getting my way again. Cool. Okay. Once that happens, you'll actually see that Pixie will refresh from the regular page to the console. So at this step, it tells you can go try a few other things. So some of the things you can do is in the CLI is do something like Pixie script list, which will actually just list a whole bunch of like pre-baked scripts we have in Pixie. So at this point, like these scripts are they're pretty full featured, but we're doing things like adding like argument support, and it'll be more understandable when I go into details. But let's quickly go check on our demo application to make sure it's alive, because otherwise we are not going to have any real data to look at. So what I did over here is I went back and typed in the command that the demo app said. It said, go to this external IP. I'll just say I want to simulate.
Yes, and just one point is we're doing it in a way where it's easy to deploy and run in Minikube and local environments. So we have some work, as Sachar brought up this morning as well, to make it leaner, but like the idea should be like in Minikube or kind, you could deploy the demo app using it in quickly, right?
Yep. Yeah, and then the demo actually shipped with load test. Like this particular one, it comes with a locus load test built in, so we can just simulate a load. Therefore, we don't have to go curl it manually. So let's just say we'll simulate 10 users, which I don't know, maybe a hatch rate of 5. So at this point, we are generating requests. So we can go and start, trying to see this data on Pixie. I'm gonna quickly show like the depth of visibility, and I'll kind of back up and then give, go from the basics of all the things that we support. So if I say PX run-L, we can basically get a list of all the pre-baked scripts inside of Pixie. So one of the interesting scripts over here is the script called HTTP data. So I just say PX run, PX HTTP data. This actually will just go ahead and dump out all the raw HTTP data it's seeing, which is pretty hard to read. So let me actually just parse it out with JQ. So Pixie can dump out data in various different formats. So one of the formats it can do is JSON, in which case you can then just pipe it to downstream tools to consume. So now it pipes it to JQ, and we can actually see, raw HTTP requests. So for example, if we go over here, we can see that there was a GET request to a path called healthz, and here was the actual response body that we saw.
Cool. Is that like time check 10 minutes, I guess? So this power.
I'm probably already way over, so I will.
No, this is fun stuff. So just go through all the commands. Like,
yep. Yeah. Anyone have any questions about this so far?
Nope.
Okay, cool.
This is looking really cool. I'm just curious, does it actually capture all the JSON payloads? How do you know that you don't get any truncated output? Like when you pass it?
So I think we truncate the output, if I remember right now, at 512K.
Oh, okay.
And part of that is because like we're mostly interested in capturing like control messages because that's probably where most of the issues are. That's where we actually want to do like deep body inspection of the HTTP requests. So we basically truncate really large requests. And we also don't show data, like over here it says removed unsupported content type. We don't show data that's not JSON.
Okay, makes sense.
Because like someone might have like a file download or something like that. And we don't really want to capture that data.
Does that also include form data and XML? I mean, I only ask because like, I think Bolt does a lot of financial work. And so like I was trying to look into using this for a particular use case, but a lot of our shit is XML, sadly.
Yeah, so we have a config setting which actually turns off everything but JSON, but we can basically dump out any format. And also, yeah, go ahead.
Yep. I was saying, is there, since it's like a stream data, which is time series, is there a way where we can build something over this data and stream it out to some backend and then, you know, visualize it ourselves? Is that possible?
You can also use Pixie's visualization. So we'll show you how that works as well. And I'll get to that in a couple of minutes, but basically in the current form, you can basically pipe the data to any other Unix command. We haven't added like full streaming support to the CLI. That's something that's coming up in, you know, maybe like the next month or so, at which point you can just run a script and it'll just keep running in the background. So you can just pipe it to some other system. So that way, if you want to take the data, filter it a little bit, capture some interesting things, and push it to Elastic, like you can totally build something like that. Let's see. Oh, the other thing I wanted to mention is that we also do HTTP2 requests. So if you have gRPC data, we'll capture gRPC data as well. And currently, we can also capture data that is SSL'd. So SSL data capture right now works for Go, but we're working on some changes which will make it accessible in other languages as well. That means that all the encrypted traffic you can go and, sorry, there's some emergency going on. I don't know if you hear that.
We're good now.
Yeah, we just hope the people are safe.
One sec, yeah.
Right, cool.
Okay. Yeah, so we can basically get like full body requests for SSL traffic. Great. So I am going to move on and show some other features of the CLI, or rather our data capture. So I showed you some of the stuff where it's like just get the raw HTTP data. We have like built-in features to, for example, show, I'm going to go from like the easiest to a little bit harder. So the easiest thing to do over here is to dump out the schemas, which is here. Oop. That copy paste. So PX schemas actually lists out, it's a very big list, but if you're interested in what data we're capturing, it actually lists out for every type of data, like what are the subfields, what are the data types, and what does that data actually mean. So if you're trying to write like custom scripts, this is kind of a good reference, or if you're trying to extend an existing script, it's a good reference to just see what's available. Jumping back over here, there's pretty simple things like note stats. Note stats basically dumps out, let me type it to less. Note stats basically dumps out information about how much CPU time like each thing is using, how much memory it's using. And there's like other really high level things like network stats. Oops. So just to show like the depth of visibility, we have things like how many packets were transferred, bytes, pretty much all the network information that you're interested in. One of the things we do is basically hook up all the data so that you can actually query data by things like pod or services or related entities. So you'll notice over here that we're actually tying all the network usage to like specific pod IDs that we're seeing. So we have this like pretty sophisticated like metadata system that actually connects all the Kubernetes metadata all the way to the low level data that we capture.
And it's
that's
fairly easy
actually
to...
all the great work from Michelle and on our team.
Zank, Kelsey might have to drop, but we could switch to, oh, Kelsey's there for 20 minutes, but we could switch to the live UI and
I'm just gonna do that next and then we can switch out.
Cool.
Okay, cool. So just to give a quick overview, I'm gonna rush a little bit, sorry. So over here, we can go to do things like take a look at service info. So this is like a very high level service overview that we have. If you take a look at this on our CLI, it's actually quite hard to see because there's just tons and tons of data. So if you have views available, you'll actually see this link pop up for the live UI. And when that happens, I had the edit view open. But when that happens, you should be able to get into a view where you can actually browse the charts. So this one over here is a latency, request per second, and error rate. And the bottom table over here is actually the request response like service map that we're observing from just like the services chatting with each other.
What service are you looking at here?
What service am I looking at? I
guess you're looking at all of them.
I'm looking at all the Sox Cloud services.
Okay.
I'm gonna do. Sorry, Sean, go ahead.
So the idea here is like all these kind of debugging scripts or just analysis scripts that you have in the CLI. If you want to visualize the results, they basically will have priority with the UI. So you can visualize, you can use the UI when you need to, and you can use the CLI when you kind of run the CLI steps.
Yep. Cool. Yeah, we're definitely moving to a mode where our entire interface is basically the exact same, whether you're in the CLI or in the UI. It's basically a set of scripts with a set of arguments. Therefore, you can basically build like a live view and then later on stick, that entire script in like a CI pipeline or something like that if you're interested in doing more live monitoring. I'm gonna do one more script and I'm gonna go to showing what's next. So another interesting thing is to take a look at something like, oh, what was the service that showed me, what was the service that had like the most, the pod that had the most HTTP data. So if I run this, it'll actually show me, oh, this is the cluster, and here was the pod that actually transferred the most HTTP data in the system. So it's pretty easy to like basically build any kind of stats based on the data that's underlying. Ishan, you said Kelsey's on for another 20 minutes?
Yeah, he's on for 20 minutes. We could, so we are at 11.
I'm gonna go to the...
Yeah, so we're at 11, so do the one more thing for like 2 minutes.
Yeah.
We'll switch to opening it up for like Q&A.
Yep, cool. All right, I have absorbed more than my 20 minutes of time, but I will go ahead and do our one more thing to show. So far...
The screen.
Sorry, what?
So you should, just for context here, so we, Kelsey had asked, we were talking to Kelsey earlier in the week, and this is something that he said that he personally thinks is important and we should work on. So we have a demo for it, Kelsey.
Yeah. All right. So one of the things we're going to try is to actually run Pixie on multiple clusters and get the results from multiple clusters back and see what happens. So let's try that out. So there's this command called PX get viziers, which is what we call our backend. And you'll see that there's one cluster that we heard from 4 seconds ago. I'm going to switch to another GKE cluster, and then we will do a PX deploy. So now it says install on the second GKE cluster. So we say yes, and that's going to install on this cluster, which should take, a minute or so.
While it happens, basically, like right now, the aggregations across clusters is going to happen on the client side. But part of like how this would happen on the server side as well.
Yeah, so the idea is that there's basically 2 sets of use cases, and so right now in the current demo, there is no cross-cluster aggregation, but we get all the data from across all the clusters. We will then add aggregation on the client side, and then eventually we'll have aggregation on the server side if you have a really large scale. Cool. So now we are running. So I can say PX get viziers, and we'll see that we have 2 clusters now that are healthy. So let me run my most HTTP data. We see that one cluster. We can pass in -d for distributed, and the gremlins are.
You need to have the demo app and stuff running there for those to show up.
Oh, I might not have the demo app running on that.
Right.
Let me.
No pressure.
No
pressure.
On Wednesday, so we got to.
Yeah, if this works, that's pretty impressive because that's like less than what 24, 48 hours, huh?
Right.
All right, I will just show something else.
So Zam, what we have to do is like deploy the demo app and
Here we go.
Get the load right, and then yeah.
Right. And instead of doing that, I will actually just show something else since it's easy for me to show this. Okay, so if I run agent status right now, it'll actually show Pixie's agent status on a single cluster, and we see the cluster ID over here, right? E3 something or another, and there's basically 4 nodes with that cluster ID. If I add in -d, we will actually see the cluster status across both the E3 cluster and the 07 cluster. So we actually have data from both the clusters queryable at the same time. I will try something a little bit more. So let's try running service info.
Right.
Yeah, no, I forgot the -d, sorry. Nope, I don't have the load test running, so sorry about that.
No, but this
I don't really want to spend like 2 minutes. Yeah.
This is super interesting because I think for most people, once you get past the hello world Kubernetes, you end up with multiple clusters, whether that's in production or testing, and not being able to deal with them as a group is really where a lot of pain exists in the Kubernetes community. I think someone earlier asked about funneling this data to another system where you can kind of do your own visualizations or aggregation yourself. I think this is kind of key to be able to say, hey, I want my data distributed across, or this query across multiple clusters, and then be able to filter something else. I think that's super critical, especially at this early stage.
Right.
Especially
Awesome,
when you
yeah.
have Prometheus remote write taking up a huge amount of memory. Being able to run these things locally on the kube clusters without taking them off is super, super valuable.
Yep. Yeah, and also I didn't mention this earlier, but our entire system collects all this data and runs it with about a little bit less than 5% overhead. So all this data visibility is coming at a pretty low cost relative to most systems available.
Yeah, that's pretty dope. I think the other thing here too is the fact that you don't really have to change the apps or Kubernetes to get and pull this data. I think that's pretty, it's pretty interesting to me.
Right. So none of the applications have been modified at all. So once Pixie is installed, it'll go and just grab all the data because we don't rely on any specific instrumentation. To elaborate on that a little bit, our goal is basically to get to like the 80-90% mark without any instrumentation. And if you need to add some like special application metrics, you can focus all your effort on that and not all your effort on adding all the generic instrumentation.
Is this 5% like per app, per service? Or
no, so the 5% overhead we measure it is actually on like a very, very loaded cluster. How much it's going to cost us to basically pull off all the data.
I uploaded the profile of my channel. Sorry, go ahead.
Are you talking about like networking overhead in terms of like how much data you're pushing around the system, CPU to gather the data from the kernel? Where?
It's CPU.
Okay, CPU across each node.
Across each node.
Okay.
There's very little network overhead in our system because we don't actually transfer the data until we actually need it. So when we're transferring the data is usually when there's actually something wrong and you're interested in getting the visibility. For the most part, we have pretty low, like just ambient network overhead.
Yeah, I also don't think there will be much in terms of memory. Yeah.
So we do actually have, I mean, to be completely upfront, we store most of the data in memory, at least for a short period of time. We compress the data a lot. So currently we restrict all of our PEMs, I think, to like 512 megabytes of memory. But the more memory we have, the more retention we can have on our system. And then we do request that the collectors be allocated like a few gigs of memory to store more data. Our goal with Pixie is to get to like 6 to 24 hours of visibility. And then after that, you know, you need to go to some other system that's really good at doing like archival store and less for like real-time data.
Is that a configurable ring buffer?
Yeah, it's effectively like every table is a ring buffer and it's configurable.
Okay.
Cool. Awesome. I'll put a
so each one more question.
Go for it.
Yeah. So each BEM is as Kelsey was saying is like a ring buffer. So there's a chance that you could write over in the ring buffer as well, isn't it? Or is there a way like you can gauge that, yeah, the ring is reaching towards the end and we flesh it out?
So we are actively working on, so probably in the next month or so, we're going to add in stuff to do like proactive sampling. So we'll basically take a look at the data. We're going to kick out of the ring buffer and be like, oh, what is the most interesting piece of information we can capture? Like, you know, out of all these images or out of all these like requests, like what is the most novel, like what are the most novel requests we can actually capture and then push upstream?
Is that based on some
so that's one of the pieces
learning model or?
Correct. We have also like prototyped a bunch of things like looking at, so one of the things we've looked at is like taking the JSON data that we observe, coming up with all the schema representations for it. And once we have the schema representations, we can basically compress the data a lot because we no longer have to, first of all, we never have to store any of the keys, like other than ones. And then second, even within the keys, there's usually a lot of repetition. So we can actually just like learn the encodings for the keys or for the values, sorry. And we can make a lot of data available for scripting. For example, if you have different user cohorts, we can expose that data without actually storing the raw field. So if you have like premium users, find me all messages where premium users was a field, doesn't actually require premium users to be like the actual user type :premium to be stored.
We actually talked about this. We're using the same behavior for internally at Lyft to reduce like Elasticsearch sizes and the amount of information we just store in S3. So understanding like your indices across your, basically the keys across your JSON objects, you can start applying this kind of strategy.
Right.
Yep.
We do, so we work with a lot of streaming companies who use this stuff for high RPS kind of streaming, and they make a lot of requests around us exposing some of these sampling parameters so that they could decide which schemas to sample versus not. So we do plan to kind of expose that as well, kind of as a second step to what Sam's mentioning. I'll take this, Mihai, you asked the questions. I'm going to use this opportunity because I think if 5 minutes, maybe if Kelsey can go over 2 minutes. So let's change gears a little bit for 2 questions we have from the community for Kelsey. And then after that, we are always on this community Zoom. So if people kind of want to kind of stick on, we can address kind of the Pixie related questions as well. So if Kelsey, if you're up for it, Mihai, do you want to relay your question for him?
Yeah, so I was quite interested when I joined this community because first Ishan mentioned that you're part of it, and you know, as an open source developer, I would like to see how I could contribute to this. Like, is there any ideas around open sourcing some parts of it, or is there any idea on how to start an open source project that would be related to Pixie, and if there would be some opportunity for me to contribute to that?
Yeah, so we were working early on with the founders that are on the call now about what that strategy looks like, and I'll let them kind of go into detail there. But there's always been a vision around having some of the key layers underneath to be open source. I think the value that's going to come from, which is, look, we have Kubernetes, we have Istio, we have all of these kind of big projects. But what's missing from a lot of them is how to use them. And I think getting metrics, for example, people writing really good Pixie scripts. So I remember when kubectl came out, we didn't have a lot of subcommands that let you do anything fancy, right? So that's still true today. People have to use Spinnaker or some complex system just to use these tools. So the thing I think that's going to be immediate, like I saw when I was at Puppet, is people really creating robust Pixie scripts that really go and get important information, do all of this stuff so that everyone doesn't necessarily have to learn the Pixie language before they can be productive, creating great visualizations. I've seen a lot of people with SRE backgrounds translate that into like reusable components and code. I think that's going to be the first place where people in this community would say, now that I have Pixie installed, where do I go find all of these modules that really make troubleshooting, debugging, and observability easy? So that's where I would start, is like creating a lot of content that guides people through this.
Very cool.
Thank you. Great point, Kelsey.
Ishan, you want to say? I have something to say, but you can go ahead.
Sure. I'll share kind of Zen and mine kind of Pixie's approach, and then switch to kind of Justin's question. So from an open source kind of standpoint, you'll see we'll be pretty open and kind of honest about kind of our approach. So when we started Pixie, like we were engineers looking to build the coolest possible tool. So as part of that, we wanted to build a tool which is like the fastest thing developers have ever seen. And as for that, we're kind of heads down building essentially a freemium SaaS product, and we're pretty open to say that. But having said that, we want to make meaningful and useful contributions to the community. So as we get closer to kind of finishing up with our beta, we want to make contributions in two fronts. One is, as kind of Kelsey mentioned, kind of basically open source some of the platform primitives. So starting with kind of the pixel scripts. Next, kind of the BPF pieces are something that we've considered, and the CLI. So what you'll see is a lot of these platform primitives getting open source to the community, like as the product matures. But our approach is we got to make the product useful. If it's not useful, then it's not that great. The second part is, which is somewhat kind of ambitious from our standpoint, is we want to make the Pixie community open and free to access for developers across the world for as long as we can. So we are in kind of, it says private beta, but anybody in the world can download and use it. And we want to make it feature full enough where medium to large size teams can use Pixie community and build around it without ever interfacing with us or like paying us. So that's kind of our philosophy. To be very honest, like we're learning and adopting as we build the product, but yeah, that's kind of our take. Zen, did I kind of cover that? If not, I'll switch to Justin's question.
Yeah, I just had one quick thing to add to there. So based on one of the things that Kelsey mentioned around having Git scripts and contributing to the actual Pixie scripts on Git, one of the things that we're planning to add in the product in the relatively near future is actually the ability to both import scripts from Git and also put all of our scripts, like actual Pixel scripts, on the Pixie community repo. So part of what this will open up is the opportunity for anyone to go create like special views. So for example, if you have a service that talks to an Elastic cluster, you might want to have like special certain metrics or certain charts, and someone can actually contribute that, and anyone else who has an Elastic cluster can then get that view.
Cool. That sounds great. Thank you.
Yeah, and hopefully, so we're sprinting to get the repo to be public. We want to add a lot of these scripts in so that you have a good out-of-box experience. But hopefully, in a few weeks, we'll open it and then you'll see the scripts come in. So with that, Kelsey, a couple of minutes. Justin, if you're still on the line, you want to ask your question. It's somewhat macro for Kubernetes in general, but go for it.
Yeah, I think maybe mine's better for a happy hour topic. So I'll respect people's time, and I'm happy to take it to Slack or whatever. I don't want to keep
Go ahead,
people up.
shoot. We're here.
I'm curious from kind of a high level perspective. And again, if this is too high level and too happy hour, let me know. But me observing the community, I'm kind of wondering if you foresee kind of continued divergence in the Kates community on tooling, or if you're starting to see convergence. And I kind of see like there's amazing opportunity with the divergence because you can spin up new tools like Pixie and also, but like, I mean, I've heard you talk a lot about, and something I'm passionate about is like all this stuff is a means to an end. Like if we're not using it to solve some real problem, that's what we're here for. So
Yeah, this is a good question actually, because where Kubernetes is right now, we're basically in the Slackware days where Linux was, right? This is before Ubuntu, before Debian. We're just now getting to the distro territory. So Kubernetes, if you look at it, the way it's modeled, it's really, we drew a line and said, no more. That's it. The core is done. We have RBAC in there. We have CRDs. We have extensibility. We have some primitive that you can build higher primitives on. Maybe deployments was a step too far. But once you start to look at that base layer, that's it. It's done. The cloud providers own their integration. So GCLB integration, all of that, that's going to be for Google, Amazon, Azure, Alibaba. All the cloud providers are going to handle that component. It's been moved out of the open source repos. They may choose to open source those components, but that's kind of a different story. CNI, again, CNI, that's one of the things I worked on when I was at CoreOS. That's pretty open-ended as well in terms of networking integration. So what I see here now is like what's missing. So when you take an average Linux distro, you install Nginx if you want a web server, or you install Envoy if you want a web server. So when I look at Pixie, this reminds me of the days when people were using CollectD, or you would pick a different tool. So now we're in the era where those APIs are so stable that now Pixie can show up and focus on filling those particular gaps without worrying about extending Kubernetes core, because I think the core has enough there for this kind of tool to exist. So I think going forward, it's going to be more like, not necessarily fragmentation, but the foundation is so strong, you're going to start to see everyone go into overdrive, rebuilding the things that you saw in the Linux world or specifically to one cloud provider. You're going to now say, well, look, if Kubernetes is everywhere, what system will we build now? All right, we were targeting Linux before. If Linux was everywhere, what would you build? Now the question is starting to shift to, if Kubernetes was everywhere and you can assume it, what would you build? That's what's super interesting to me. And that's why I think that now going forward, we went from configuration management and automation to API-driven infrastructure end-to-end with semantic data and meaning. You get tools like this. So that's what I think going forward. It's a good question, by the way.
Thank you. Appreciate it.
Awesome. Thank you so much, Kelsey. Kelsey's been super helpful for us to like shape the product. Like we're a bunch of like data ML people trying to like build something somewhat ambitious, but he's helped us shape it in the right direction. So as much—
It reminds me of my CoreOS days. I've been gone from CoreOS for almost 5 years, right? They got bought by Red Hat. But this feels like the same thing where you take something cutting edge and you try to make sure that it's actually operational for the people who have to use it, like the early days of CoreOS trying to take Docker and make it operational. And then honestly, this thing all works well if the community jumps in and do things that we can't imagine yet. That's the Docker moment that's probably waiting to happen in the space. So look, I'll be around quite a bit at these community meetings, and I'll probably be around on Slack every once in a while. So if you have questions about this or just anything in general, we'll love your perspective. I got to drop, but it was nice being at this particular one. So shout out to all the Pixie Knots.
Awesome. Thank you so much, Kelsey.
Thank you. Thanks a lot. Yeah.
Thank you. So that is probably the perfect point. So we'll do two things before we wrap up. We'll send the notes and the video. Zen, it'll be great for you. Just gonna give you a sneak preview of the roadmap, like the next set of features, so that the community holds us accountable. So that next time when we demo, you see this stuff being real. And then we have one big and existential question that Rupak posed. Zen, if you want to cover that, which is, why do I use Pixie if I have Datadog, and like what is the use case? We're just going to cover those two things, and then we'll break.
Yeah, so I think one of the things is Datadog has a lot of features, and we don't aim to have feature parity to Datadog anytime in the near future. Our goal is really to provide the best like debugging experience for like real-time debugging. And we plan to like exist beside Datadog for now.
So I think like there's another question which I had, if you don't mind me asking, it is basically like, how, like, if I'm going to go and install this, right? It's very like, what would be the way that I would transition developers from trying to force stuff into Datadog for debugging, which is what they're doing right now, right? Like we send a bunch of metrics, we try and force anything we can into Datadog so that it's queryable in some form or fashion. It's not as extensible as this, but what is like in your mind the best way to transition to using something like Pixie while making sure that you can continue to have like usability to everything?
Sure. So I think if you're using Datadog and you're using like the standard doc_stats_d and everything, we should be capturing that data. So you don't have to do anything additional to grab like the basic data that Datadog is already capturing.
Right. And then from a usability standpoint, Rupak, like what we've seen, and this is again like our hypothesis, which is initially getting like validation or refinement, is trying to have developers run kind of scripts in their dev workflow. So a scenario would be Pixie's running in their dev cluster. They essentially run a Pixie script to get the service stats in their CLI or inside VS Code without having to like punch out to a pre-configured dashboard or creating that on their own. So like getting developers to use data and interface with that through like the Pixie API is kind of what we're optimizing for. In terms of the nearest term, is basically kind of a learning curve through like Pixie scripts. Hey, here's a few basic checks that you could deploy, and this comes out of the box. So one thing is essentially kind of a use cases around integration testing, or whether you have kind of self-test. Basically, like small Pixie scripts become like your Lego blocks to get developers to use kind of not Pixie specifically, but use data in the developer's workflow. Success, to be very honest, so we are open to share. Like we work with, for example, Disney and like teams like Hulu. And honestly, like our goal is when Hulu has an performance outage, like in the war room, they all have Datadog. Like one developer has Pixie and gets to be on and anything else, right? So, but that's only possible if the developer is comfortable with kind of basically tinkering with like the Pixie data. Does that make sense? But so a lot of our docs and everything that you'll see will be around like these Pixie scripts and Pixie playbooks. And then the idea would be these playbooks become part of their workflow.
Yeah, that makes sense.
I can also add something to it. So I've been in situations where we had our own in-house system for analyzing performance or debugging, and it was all based on specific collectors and then Grafana, like looking at it. We had issues where we actually wanted a scalpel and not like a big dashboard to just give us outputs. And Pixie looks like something which can be a scalpel where you can pinpoint and just go and get information and then actually identify, yeah, the issue is lying there. So the fact that it's like a very holistic thing where you can get all the information, like a high level information, and then start digging down deep into specific, values coming out from the collectors. That's something we need.
This CLI reminds me, like, it makes me think of having a distributed top for Kubernetes, where you just see like high CPU usage, high mem usage right away, and immediately pinpoint stuff with a couple of commands. Right. That is something that doesn't exist anywhere right now.
Yeah, I mean, I think Pixie is distributed top, distributed netstat, distributed CPU dump, and all of those, essentially.
Right. And we're coming from like the data, give data, kind of the power of data to the developer in the lowest friction form factor possible. And a lot of these use cases, we're pretty open. Like we're open to kind of emergent use cases. We're starting off with kind of the debugging use case, but people are already starting to use it in a bunch of different ways. Then a roadmap and then wrap.
Yep. Yeah. Quick roadmap.
You can open up the docs. I think it's the key things.
Yep. Cool. So what's coming in the next 4 weeks. So part of the things that we're working on is actually getting the live UI to, so the live UI right now, it's only accessible behind the hidden link. We're pretty much building everything out in the open, right? So anyone can go hit it. It's not actually blocked, but it's got a ways to go before it gets to our vision of where we want the live UI to be. So I will quickly just like walk through where we see the live UI going. So this is like a quick video walkthrough of the live UI. So we have like a very high level overview of like what services are, oh, sorry, it's a video. We have a very high level overview of like what are the namespaces, services, entities, and then different clusters that you've looked at. Part of what we're pretty excited about is actually converting everything to this command-driven interface, where effectively you can type in a bunch of commands that are actually just like Pixie scripts under the hood. And they take in a set of arguments behind like an autocomplete. So it's like a very easy way for you to navigate across a set of services or pods or clusters and pop into a very high level view of the service. For example, over here, we selected the front end service in Sock Shop. So when you go to that, you will actually see this view. What I'm gonna do right now is actually walk through like a very specific debugging scenario. So this debugging scenario is called the noisy neighbor problem, which is someone launches another pod or something on your cluster and it lines up utilizing a lot of resources and messes up the performance. So part of what we're interested in investigating is this latency spike over here. So part of like Pixie's like deep linking and debugging allows us to go and select this blob of text. And based on that, we will take a look at trying to figure out, based on what we saw as the normal before, what are the actual factors that are affecting the latency at this point, right? So how are these points different than all the other points that we've seen before? And we noticed that there is a high correlation with a particular node and availability zone. So one of the things that you would do is just go and then click on the actual node level view, and it would pop us out into the node level overview. So the node level overview over here, we can actually see that, oh, there is a jump in this new pod called Chaos Kill got started, and that's at the same time that there was a performance issue, and it's also utilizing pretty much all the network resources available on the machine. So that was part of the reason that we saw the latency spike. So that's kind of like step one towards where we're building towards. The other thing that we're working on is actually trying to make these scripts easily shareable. So once you're at the video is not cooperating with me. So once you're in the edit view, you can basically go and hit share and share this script either on GitHub or by URL to another member on your team. So that's probably like slightly like midterm, like maybe in a couple of months, but all of our scripts in a couple of months will get backed by a Git repository, which is either a repository that we set up for you or a repository that's for your team. And one of the other things I guess we wanted to mention quickly based on the doc, is this pixel script compression. So we, in general, don't expect most users to just go start writing like Pixie scripts, right? So we think that a lot of the Pixie scripts are going to get initially written by us, and some of them will get extended by some of our community members based on the samples that we provided, and just adding like more and more things to it. But one of the things that we noticed about our Pixie scripts, even when we are going through it, is that in our current form, we basically have essentially a Python DSL that generates the data. Then we have this spec called Vega spec, which is actually this JSON spec for all the charts in our system. And then we have a file called placement, which actually figures out where the widgets are located. Vega is actually like this high-level visualization library, but it's still pretty cumbersome. So one of the things that we're doing is actually moving most of this configuration, because we have like a domain-specific view. So we have like certain things to think about, right? There's like time series charts, and there's like status code charts and things like that. And we're basically just going to add that as decorators to Python functions. So that'll make the language much more compressed and easy to understand.
Right.
So that should be coming down, probably within the next month.
Right. And then we do like the philosophy is like we want to make all the kind of easy problems easy through the live UI, but the hard problems possible. So we do want to set it up where people who are not kind of Pixie nuts or Pixie members to write their own scripts. So it'll be a continuous process to make it simpler. But right now, even for us, it's a wall of text. It is a lot. Philip, who's on the line, is our in-house script master. So if you go to the live UI, you'll see script coming up. That's primarily from Philip, but we'll make it simpler. All right, we're at 11:31. Hopefully this was fun and helpful for folks. It is. We do have an interesting take at this use case, and this is a work in progress. But appreciate all the feedback and support. If you have any questions, ping us anytime. We're on this Zoom call as much as we can, and we're on Slack. What we'd want is this brutal feedback about like what we need to evolve Pixie into for it to be useful, like whether that's features or specific views or scripts, and we'll crank them out. Our only asset is like velocity, so we'll do that. That's it. We'll share the recording and the notes to the email list, and then hopefully we see you again in the next meetup as well. Thank you so much. Have a good weekend.
Yeah, thanks everyone for taking the time.
See ya.
Thank you, guys.
Bye, folks.
Good.
Bye.